I'm going to talk again today, but about a different type of project. This one, instead of looking at the water side of things, was looking at the fertility side, specifically whether we could inoculate wheat seed with a nitrogen-fixing bacteria and have the nitrogen-fixing bacteria supply a little extra nitrogen to the wheat crop in 2021. And this was really, it's Paulo's trial. Paulo, although he wasn't able to make it up here, he wasn't feeling very well last week, so decided to stay home, and I am presenting. We did run this trial. We ran it at the Southwestern Research and Outreach Center in Lamberton, which is about 5 hours south of here, and in Crookston. So we've got a northern location and a southern location for this trial. The rationale for this work is to use growth-promoting bacteria in order to see if we have any effect on, improving the soil microbial community and fixing atmospheric nitrogen being kind of the main goal to kind of make the, because the atmosphere is fixing nitrogen, obviously our would supply nitrogen to your soybean crop, but could we apply kind of a similar technique to making wheat sort of fix some of their own nitrogen? And there's also been some research that shows that inoculating it with this nitrogen-fixing bacteria can help improve plants' ability to handle stress. So the objectives for this were to look at whether inoculating wheat has a positive impact on wheat growth and yield, and to also determine the best inoculation rates, whether you're in northern Minnesota or southern Minnesota, and then looking at the soil organic, inorganic nitrogen, and the total nitrogen uptake in the grain, so kind of looking at soil fertility, but then also yield and quality with and without inoculation. So there are really two separate trials going on. We looked one where we looked at nitrogen rates, and another where we looked at inoculation rates. We basically had the two different field trials. The nitrogen rate study looked at rates between 0 and 120 pounds per acre of nitrogen applied to wheat crop, and with kind of a standard inoculation rate of that nitrogen-fixing bacteria at the recommended rate. Paulo had got this particular strain of nitrogen-fixing bacteria from basically Brazil's version of the USDA, so he used their recommended rate of 1.3 ounce per acre. And then so we also looked at that with looking across some different rates: a half rate, full rate, double rate, and 4 times the rate, or 3 times the rate, with 0 and 45 pounds per acre nitrogen. And we looked at 3 different locations. We looked at wheat after soybeans in both locations. We looked at wheat after corn in Lamberton, and then we looked at wheat after sugar beets in Crookston as kind of a specialty, regional specific crop to look at. We collected soil samples before planting and then after harvest to analyze for nitrate and ammonia. And those grain samples were collected and analyzed also for total nitrogen content and grain yield. Okay, first we'll talk about the results for Lamberton. Lamberton actually had a lot more interesting results than Crookston, which I'll get to in a minute. There were significant differences in Lamberton for post-harvest soil nitrate for both wheat after corn and wheat after soybeans for both studies. So we did see an effect of that nitrogen-fixing bacteria there, but we didn't see any significant differences in the soil ammonia, that's the soil organic nitrogen, and there wasn't any difference in grain yield across those different inoculation rates. So these are the results for Lamberton for the amount of nitrogen in the soil. And what you can see is that there's kind of a trend. The darker bar is the inoculated plots, and the lighter bar is the non-inoculated plots. There was a significant difference at the 120 pounds of nitrogen applied for inoculated versus the non-inoculated for both the wheat after soybeans and the wheat after corn. And this is kind of the same information kind of presented a little bit differently. You can see this trend of there was more residual N left in the soil after with the non-inoculated wheat than the inoculated wheat. So we're seeing again that effect of that nitrogen fixing bacteria being able to supply additional nitrogen above and sort of beyond what we applied in those plots. And these are the results. The same thing, the soil nitrogen levels left over, but looking at the different inoculation rates. And there's a kind of a general trend here of the inoculated plots having more residual nitrogen than the non-inoculated plots. And that was true at the half rate and at the double rate, but not for the other rates, so I'm not sure, sometimes funky things happen with the data. But in general, you could say the trend is that inoculations at kind of whatever rate we used, were able to fix extra nitrogen. And then finally, kind of, the grain yield picture, that is a little bit less of a significant effect there. At the 0 pounds of nitrogen applied per acre, we did see a significant increase in grain yield. So if you applied no nitrogen, but you inoculated it with this bacteria, you would get a boost in yield. So that was good. Again, kind of that general trend of seeing increased yield, but not statistically significant, except for wheat after soybeans at that 100 pounds per acre application rate. We did get a boost in yield from the inoculated plots when we had plenty of nitrogen already applied. In Cribston, we didn't actually see any significant differences in the wheat yield or the soil ammonium, which again is the soil organic nitrogen, but we did see some significant differences in the soil nitrate. We didn't see much of an inoculation response in Cribston. This is a picture that I took of the trial in about July. For whatever reason, this particular trial just didn't take. And I think it's really a factor of the drought and the extreme drought. This whole area of the farm didn't have very good wheat yields this past year, and this trial was no exception. So it's really hard to say. I mean, I think nitrogen was not our limiting factor on yield this year. I think it was definitely water, especially up north. So yeah, these, we actually had trouble even getting these plots to come up. We almost replanted them, but then they kind of sprouted a little bit. Maybe we should have replanted. These are the same questions you guys always ask yourselves. But we're hoping to be able to repeat this next year in a year where at least we're starting with more soil moisture to see if our northern location can do a little bit better. But we did, again, kind of see a significant difference in grain yield. If you applied no nitrogen, but you inoculated with this bacteria, we did get a boost, a significant increase in the grain yield. So kind of have a proof of concept despite all of the difficulties that we had getting that trial established. So in summary, at Lamberton, when Paulo looked across the data, he noticed that the wheat yield was increased by about 15% when an effect was observed. And soil nitrate levels were 111% higher in the inoculated plots when a response was delivered. And of course, again, for Cribston, the only significant difference was in grain for wheat after soybeans, kind of inoculated versus not inoculated. But we had inconclusive data for the sugar beets kind of all together, basically because we had trouble getting that trial to establish. So, thank you guys for your support of this work. If we have time, I'll answer some questions, or at least I'll do my best to answer some of the questions that you have. Yeah, that's a good try to get the mic over to you guys so that everybody can hear your questions.
I was wondering about up there where you had that increase in the yield. Did your wheat quality stay up there the same, particularly the protein? But
yeah, I think the yield was increased, but the quality wasn't significantly different. So, yeah, that's.
Is this a natural strain, or is this in our soils, or is this what is the name of the bacteria? Is it rhizobia soybeans that we're using?
Yeah, I'll just repeat that question really quick. He was asking, if this was a native bacteria that we were using and what the name of it was. I actually don't remember what the name of it is off the top of my head, but it is something that does naturally occur in Minnesota soil. So we weren't introducing a new thing. It was just kind of boosting the population. And it's something that there's another faculty member in our department. So Paulo and I are in the same department, Soil, Water, and Climate Department in the Twin Cities. There is a faculty member who thinks he's going to be able to isolate that particular bacteria, for us, so that we could actually, not have to ship the bacteria in from somewhere else to do the trial.
Sorry, maybe I can help you.
Yeah.
We were talking with Dr. Pagliari yesterday. You said it was a strain of Azospirillum. I don't remember the exact one, but it was Azospirillum, was the bacteria.
Thank you.
Yeah, that was sort of my question too. The Azospirillum did you use Brazilian? You used Brazilian?
Yeah, the inoculum was actually shipped from Brazil, so they prepared it for us, and then we kept it cold and inoculated. We inoculated the seed and planted like the same day. Basically, we prepped the seed, I handed it off to the farm, and they planted it immediately.
Does the amount of organic material in the soil affect the efficacy of the bacteria?
Yeah, that's a really good question. I mean, I think that it has to, because there's a lot of conditions for microbial, for the microbes to kind of do their thing. They need, the right environment, but they also need to have the right, carbon and nitrogen levels. So, and moisture. I mean, they also like it to be a little bit moist. So yeah, I think there probably is a little bit of an effect of some different, soil things going on beyond what we looked at here, which I think would be a good thing to kind of keep an eye on as we move forward.
I had a question about, can you go back a couple slides? I wanted to see one slide.
Yeah.
But one comment I thought was, you're inoculating the seed prior to planting. Is there going to be any benefit to somehow getting the inoculant into the soil prior to planting to get some development of the bacteria before the wheat's grown?
Yeah, I think that's a really good question. I'm not as, and that's where I'm not as familiar with the research that's been done, in Brazil, that when Paulo kind of took the baton on this. But yeah, I think the idea of inoculating it with the seed is so that the bacterial community is right close to the seed. But at the same time, I can also see what you're kind of saying about if you could sort of maybe inoculate the soil and give it more of a head start, because that would be a challenge, right? Is because if for some reason, the community isn't happy when you inoculate it with the seed, then you get one shot with it. But if you're establishing it ahead of time, I think it's a really, really interesting question and something that I'm going to ask Paulo.
Looking at this slide, I was just kind of amazed that the 0 nitrogen inoculated compared to the 120 pound non-inoculated looks about the same yield.
Right, yeah. Which again is kind of where I sort of wonder, we're nitrogen limited this year, we were definitely water limited is one of my thoughts.
Any questions for Dr. Pease? All right. If not, thank you, Dr. Pease, for interesting presentation, and hopefully we'll be able to look forward to hearing more about it in the future. Thank you very much.